Hi, welcome to Nomi's Academy. In this video, we are going to learn the rules of differentiation. There are different rules of differentiation. They include sum and difference rule, chain rule, product rule, and quotient rule. But in this video, we are going to learn the sum and difference rule. So we are looking at sum and difference rule. Alright, so whenever or if y, a function of u and v, where u and v is also a function of x, then the derivative is going to be a sum of their derivative, du over dx plus dv over dx. Also, if y equals to u minus v, u and v are both functions of x. Now the derivative, the y all over the x, will also be the difference of their derivative. So we have the u over the x minus the v over the x. Okay, let's pick our example. The first one, example 1. Find the derivative of y equal to the square root of x minus 1 over root x plus x raised to the power of 3. Alright, this is a function and we are required to find the derivative of the function given. Now we are going to use the sum and difference rule for the problem given. Alright, as you can see, we have the negative sign here and we also have the positive sign here. So that will be the y, the x. Let's write all this, or before we do that, before we start looking for the derivative, we need to write this in index form, to write it in the proper form so that it will be very easy to differentiate. So we have y equal to x raised to the power of half. So square root of x is written in index form as x raised to the power of half minus 1 over square root of x in index form is written as x raised to the power of minus 1 over 2. In case you are in doubt of this solution, you can as well check the topic in your SS1 textbook, indices, where you will see the different laws of indices. Alright, the next one we have is x raised to the power of 3. Alright, finding the derivative of the function, and that will be the y over the x. So we are going to find the derivative of this function, 1 over 2 over the x minus d of x raised to the power of minus half over the x and or plus d of x cubed all over the x. Alright, to proceed further, the y over the x is equal to, you can remember in the previous video, I explained how to find the derivative of a polynomial function. You know this is the power. Half is the power of the expression and 1 is the coefficient. So 1 multiplied by half is half. X raised to the power of half minus 1. So we have differentiated this function. We move to the next, minus. To differentiate this, minus 1 over 2, we multiply the coefficient, which is 1. And that will give us minus 1 over 2. And here we have x raised to the power of minus 1 over 2 minus 1. Okay, then we move to the next one. To differentiate this, we have 3 is going to multiply the coefficient of x, which is 1, and that will be 3x raised to the power of 3 minus 1. 3 minus 1. Alright, so we have the y over the x equal to half minus 1 is minus half. So we have the coefficient, which is 1 over 2x. Half minus 1 is minus half. Okay, here we have minus minus, which is plus. So we write plus half. And then we have x raised to the power of minus 1 over 2 minus 1, and that will give us x raised to the power of minus 3 over 2. You can check it out, look for the LCM, and then you solve it further. So, minus 1 over 2 minus 1 is minus 3 over 2. Then we proceed to the next. We have 3x raised to the power of 2. 3 minus 1 is 2. So, as you can see, this is the solution to the problem. We can go further to introduce the square root sign. And that will be dy dx is equal to 1 over 2, or we write it this way. Since we have minus 1, we are transforming from the index form to the standard form, and that will be 1 all over 2 square root of x. And then the other one we also have plus 1 all over the square root of 2x. Square root of x multiplied by 2, all raised to the power of 3. All raised to the power of 3. And then the next one we have, this implies this. That is 2 into 1 over root x, all raised to the power of 3, plus 3x squared. So this is another form we can express the solution. Let's pick another example. Example 2. Find the y, the x of y equal to 3x squared minus 5x cubed minus 3. Okay, so we write the problem again. Y equal to 3x squared minus 5x cubed minus 3. Now to find the y dx, that will be the y over the x equal to, we are going to differentiate this, and that will be 3 times 2, x raised to the power of 2 minus 1, minus 5 times 3, x, 3 minus 1. And when you differentiate a constant, the result is going to be 0. When you differentiate a constant, you get 0. So dy over the x is equal to 3 times 2 is 6x, 2 minus 1 is 1, so you have 6x, minus 3 times 5 is 15, x, 3 minus 1 is 2, and that is 0. So this is the result, and that is the final result. Alright, take this as the assignment, and then you share your answer in the comment section. Alright, we have find the y dx for y equal to the cubic root of x minus 1 all over the cubic root of 2x. Thank you for watching. See you next time. Bye.